Hello again. We are continuing our discussion of functions by talking about how to evaluate those functions. So let's get started. First of all, let's talk about what function notation looks like. Okay, normally we write an equation as something with y in it and x in it as well, and we write it as y equals 2x plus 1. Well, what you need to know is that y can be replaced by this f followed by x in parentheses. And how we say that is f of x. It is a function of x. Okay, so that can replace y whenever you want it to. Then, if we want to evaluate that function, we can replace x in parentheses with different input values, and we can calculate those output values. So x will represent our input values, and then whatever f of x is as a result, that will be our output values. Okay, so for example, if I replace the x in parentheses with 5, that means that on the right-hand side, I need to replace every x with that same 5. So f of 5, that's how I would say it, would equal 2 times 5 plus 1, and that equals 11. Okay? If I instead replace x in the parentheses with -3, then to evaluate that function now, I would calculate 2 times -3 plus 1, and that would be -5. And similarly, if I replace that x with 0, then I need to calculate 2 times 0 plus 1, and that would equal 1. Okay, so if I have more than one function, I can't use y for every single one because y can't represent two or more different things. So what I do is I use more letters for those functions. So if I have a function that's x squared plus 1, I could call that f of x equals x squared plus 1. A second function is y equals 3x plus 7, so I could call that g of x equals 3x plus 7. And then a third function would be y equals 10 minus x. I can call that h of x equals 10 minus x. So if I want to calculate f of 5 plus g of 3 minus h of 8, what that means is I'm going to replace x in the first function, f of x, with 5. And then I will replace x in the second function, g of x, with 3. And then I will replace x in the third function, h of x, with the number 8. And I will figure out what all of that is worth. Okay, so f of 5 would be x squared plus 1, but x is replaced with 5, so that would be 5 squared plus 1. G of 3 would be 3x plus 7, but x is replaced with 3, so that would be 3 times 3 plus 7. And then h of 8 would be 10 minus x, with x replaced with 8, and that would be 10 minus 8. So you see how the substitution works there. Now all I need to do, since all I have is numbers, is just evaluate everything. So 5 squared plus 1 is 26, 3 times 3 plus 7 is 16, and 10 minus 8 is 2. So 26 plus 16 minus 2 would give me a final answer of 40. All right. Now, sometimes I would use variables for this, and that shows up not only in this course, but in Algebra 2 and Pre-Calculus and in Calculus. So we need to know how to do this. So I'm using different functions, but I'm still calling them f of x, g of x, and h of x. And you can see them there. So if I wanted to know f of a plus g of b plus h of a squared plus b, then what that means is in the first function, I'm going to replace every x with the letter a. I'm going to replace every x in the second function with the letter b, and I'm going to replace every x in the third function with the expression a squared plus b. And I'm going to see if I can collect like terms and simplify and all that good stuff. So the first function, if I replace x with a, I get 2 times a squared plus 3. If I replace x with b in the second function, I get 5 times b minus 1. And if I replace x with a squared plus b in the third function, I get a squared plus b minus 6. So if I evaluate all of that out, I get 2a squared plus 3 plus 5b minus 1 plus a squared plus b minus 6. And that all simplifies to be 3a squared plus 6b minus 4. And that's how you would evaluate functions if you had variables instead of numbers. We're going to talk about both of these tomorrow. If you have any questions, please let me know, and I will see you tomorrow.